heading one and the vocab one. If you didn't get all the vocab, you could try to get snippets of it that's up there. We're going to fill some other things in on the notes. These notes will not, obviously, it wasn't on the list. It's not going to go in this notebook check that you get to on Thursday. Okay. So you'll hang on to it for second semester. So it'll be the first one on the list for second semester. Okay. And then also we won't test on this before break, so we're going to want to have those. Okay. Clarification on the notebook on Thursday, they are due. Okay, that is not the time to try to figure out if you've got everything on Thursday. That's why I gave you the handout last week. Okay, so when on Thursday, I'm going to give you one of these folders. Okay, you're just going to put your name at the top, and then you're going to put them in here and just make sure that they are in that order that is on there. Okay. Highlight, I want each of the, not the whole definition, because otherwise you might as well just leave it blank. If the whole thing, it just makes it hard to find it. So you're just highlighting the vocab word that is on there, okay? So then we can say, oh, here it is, and then I read the definitions, and then we just check them off as we go through them on Friday. But they're due on Thursday, okay? So that I can hand them out on Friday. Yes?
About like the vocab word on the paper where it's bolded, do you have to highlight those?
No, if it's already bolded, then it already stands out. So we just need it to stand out, okay? Yeah.
Will underlining work and stuff?
Yes, if that's obvious, yes.
I have number 9, does that work?
That's perfect. I just need it to stand out so it's easy for the person. So they're not trying to look through like this paragraph thing trying to find the word. It's like, here it is, okay? So whatever that may be. Yes?
So do you want us to take a page reader out of our notebook?
Yeah, you'll clean out your notebook, start over fresh. And if you need these, I keep these for some reason if you want them back. Okay, it's just to clean them out because we're done with first semester. Okay. Also, I've got mine put together, so, and I highlighted, this will be how when we grade them. So if there's some, oh, there is one I want you to cross off on the list that I'm sure some of you figured out. So I've got them up here just so you know, like, do I have them all if you're like curious? I'm pretty sure if you compare to somebody next to you and they have the same thing, you're probably good, okay? So the one thing, it was in section 1.3, it's the very last one. It says, then paper with 2 drawings that you measured. In the past years, that was one that I handed out a thing and you had protractors and you actually measured it. I didn't do it with you guys because the majority did not have their protractors bought yet. It was right before we started using protractors and compasses. So I did it on the board, and it was the one where we had, if you know 2 angles, we can find out what the big angle is by adding them together, and that's what that one was. So if you don't have the paper, I just did that with you when we did those. Okay, so that one's not on there. And so I altered it, so it won't be out of, I think I said 850, so it's 840, okay, because it was, for measuring those 2 as 5 tenths, which is still significant. Okay? Any other questions? Please, guys, this is like really not math. It's just copying something down, showing that you, those days that we spent taking notes where you have a whole class period to get vocab done, that this is your chance to show that you did these. Yeah?
If some of your vocab words are like out of order, is that
okay? As long as they're close. They should be close to each other. Yeah.
I have one that I think I just accidentally put on a separate paper because I had to make it up or something. So if I just write a note saying the rest is on the next page, okay.
Whoever, yeah. Because the idea is not to make it tough on the person that's grading it. If it's in order, this should be an easy check off thing, okay? Or maybe put a post-it on it, okay? Because you're not handing in that sheet that I gave you. You're getting a fresh one that actually has the points on it. So, okay? We good? Yeah, some people wrote their notes like front to back and then were absent, so like they started their next section and then realized that they were absent and never made it up, and so now it's not in the right order. So if that's the case, that's fine. Just make sure you're like putting some type of post-it, hey, my section 2.5 is after this section or something, just to make it easy on whoever's grading. Okay, any other questions? Okay, so Thursday by the end of class you'll be handing those in. Okay, so angles and polygons. This was actually one of your it was the only geometry, kind of geometry one that was on there. So if you watch the video or the hints, you'll already know about this section, okay? So polygons, remember, have to have at least how many sides? 3. Ooh. Yeah, let's put a finger down. Polygon has to be at least 3 sides, right? So it's a triangle and up above, which you started a chart that has the 3 sides in a triangle, okay? How much does the inside angles add to equal on a triangle? 180. Okay, so we need to keep that in mind for this whole section, okay? So we're relating all polygons to triangles and how we can figure those out. Okay, so the 2 first definitions that you had on your sheet below the cutout paper thing, and we'll talk about that in a minute, was convex and concave. So convex, and they drew an example of what the definition is saying. So a convex polygon is one in which no part of a line segment, and so the line segment they're talking about is the red one there. Okay, line segment connecting any 2 points on the polygon is outside of it. Okay, so if I were to connect like this side, okay, to this side, it's not going to be outside the shape, okay? Or even this side to this side, that line is still not going to be outside the shape, okay? So convex polygon looks like this, okay? Concave is the opposite, okay? I could still like draw one on the inside, but it's not all of them, because if I were to connect that side to that side, they show it's on the outside. And really, the only way that I remember the 2 and not get those confused is this word right here, okay? When you think of the word cave, right, it goes in, okay? So concave, on one of the sides, it just goes in. Convex, it's a solid shape. It doesn't sink in, okay? So those are the difference between the 2, okay? So cave comes in, convex stays out. Okay, so we have a pentagon. Pentagon is how many sides? 5. Okay, so keep that in mind. So we have 5 sides, and you just said that triangles add to equal what? 180. Okay, so on your shape, you should have, this was one that you were supposed to have drawn, okay? So on your shape, 1, 2, and 3, okay, so we're going to write, you don't have to write the measure of angle 1, just go 1 plus 2 plus 3, okay, next to your shape, equals what? Because it's a triangle. Angle 1, 2, and 3. You just told me the answer. Okay, 180. Okay. Okay, then either next to it or below it, it's at the bottom of your notes. Right, 4 plus 5 plus 6. Well, angle 4 plus 5 plus 6 is still a triangle, right? So that adds to equal what? 180. Do you want to guess that last one? 180, because 7, 8, and 9, they add to equal because it makes another triangle to be 180. Okay, so if I were to put these together, okay, to figure out what all of these are, plus this one down here, oops, what do you think I'd do with 180? Three, because you have 3 triangles, right? So if that's a triangle, that's a triangle, and that's a triangle, I could go 180 plus 180 plus 180 to find the sum of all the inside of that shape, okay? So there was 3 triangles, okay? So you can multiply 3 times 180, okay? What about a 4-sided shape? If I choose one vertex and draw to all the other vertexes, okay, so say I chose this one right here, okay? And I draw here, there's already a line there. I draw here, there's already a line here. So I just need to draw one here. So you make how many triangles? 2. And the inside of a quadrilateral or a square or a rectangle should add to equal what if there's 2 180s?
60.
Okay, so your pie pieces that you did, your quadrilateral, okay, that was the only one that we did the inside and the outside, okay? So those pie pieces, you had 4 pie pieces, right, that you put together and it made a circle, which was, what's the circle? 360. And we just said 180 and 180 is 360. Okay, so we're going to look for a pattern here because we're working towards our chart on that. Okay, so a triangle is 180, so that has 3 sides. This one right here had 2 triangles, so we said that that's 360. So that was 4-sided. 5-sided, my calculator people, 3 times 180 is 3 times 180. 540. Okay, so we're looking for a pattern to start filling out in our chart. Okay, I want somebody to try to see what is happening between the sides So we started with 3 sides, gives me 180. Okay, 4 sides gives me 360, which gives me 2 triangles. 5 sides gives me 3 triangles. So 3 sides gives me 1 triangle. 4 sides gives me 2 triangles. 5 sides gives me 3 triangles. You notice a pattern in those numbers? Each of them have, if you look from 3 to 1, 4 to 2, 5 to 3, they're subtracting how many? 2. Okay, so where this is coming from is when you choose one vertex, doesn't matter how many sides there are. So say I had a 20-sided figure, okay? When we choose one vertex, and if I could actually draw that, it might kind of look like a circle because it's getting wider and wider. If I choose one vertex, I'm already drawing to one of them, right? Just like we did here. We already draw to one side, okay? And then we draw to the other side. Same thing here, they chose this one. It's already drawn to that side, and it's already drawn to that side. So these two right here is where the -2 always comes from. Okay, so it's a lot harder to always have to draw the triangles and then count how many triangles we have. If we could just say, how many sides do we have? Well, I have a 20-sided figure, and I'm going to subtract how many from it? 2, and then whatever that number is, I'm going to multiply it times, what was the shape that we're coming up with? 180, okay? So we're learning a formula to solve for these. Yes? Okay, let me draw it where it's not all over the top of everything here. Okay, so when we have, I'm just going to draw some random shape, don't know how many sides I'm going to wind up with. Okay, hope something like that connects. Okay, so we want to figure out how many triangles can be created. Okay, so if I just choose one vertex, doesn't matter which one you choose, you're going to choose one vertex, okay, and I need to draw all the other vertexes or all the other angles. Okay, this one right here is already drawn, right? Because it's the side. And the same thing here, this one's already drawn, okay? But I need to draw to this one, and then to this one, and then to this one, okay? So I would have 180, 180, 180, and 180. So I have 4 of them, right? Okay, so I wound up with 4 triangles. But this was a 1, 2, 3, 4, 5, 6-sided shape, right? So 6 minus 4 is 2. So no matter how many sided shape it is, it's always going to be a -2 to figure out how many triangles you have. Okay. So it was the same thing when we had the square, right? Square when I chose 1, okay, that has 4 sides, but it only made 2 triangles. 4 minus 2 is 2. Okay. 3-sided figure, I only have 1 triangle. Well, 3 minus 1 is 2. So every single time that will tell you how many triangles you have. It's a lot easier than having to draw the lines, put, how many 180s we have and count. So if you had a 20-sided figure, how many triangles are you going to have in it? 18. And then you go 18 times 180. Okay, because 180 is the triangle. So it all has to do with the triangle. Okay, so we're going to start filling in our shape. Or our chart that is on the back. So the chart that was on the back was actually, there was 3 separate charts in the book, if you go to the book. But I didn't want to have to draw 3 separate charts because the 3 charts had repeating stuff that was in it. So I just made one chart with just to make sure we have each one of the columns. Okay, so we should already know the number of sides for this one. Okay, so triangle has how many sides? 3. Okay, so we're going to fill this in. Quadrilateral has 4. Pentagon, 5. X, remember what the X? 6. And then n-gon just means I don't know how many sides. It just represents the sides. So we're just going to put n. Okay, so n is the number of sides. It's just a variable. Okay, they could have used x if they wanted to. Okay, well, for a triangle, we already figured this out. Okay, for a triangle, there is only one triangle. Quadrilateral had how many? 2. Okay. And then we did the pentagon one, which was the one where you had the drawing on the first page. Okay, it was 3. So we should be able to figure out this one because we figured out what the pattern was each time. They were subtracting what? 2. So 6 minus 2 is 4. Okay? And then whatever the number of sides we have, so that's n, we're going to subtract what? 2. Right? To figure out what it is. So just like we said with the 20-sided figure, we'd go 20 minus 2. So whatever n is, we're going to subtract 2. Okay. The other one show up, the troublemaker? About time. He doesn't even know what I'm talking about. Okay. Not you this time, Brody. Okay. Okay. So sum of the interior angles of a polygon. So we are filling in the blank. This is on there. Okay. So it says the sum of the measures of the interior angles of a polygon with n sides is going to be n minus 2. So we're filling in a formula, n minus 2. And then once we know that, we multiply that times, what is a triangle? 180. Okay, so like the 5-sided figure, right? We went, which was the pentagon, we went 5 minus 2, which gave us 3 triangles, and we said we went 3 times 180. Because that tells us how many triangles we need to multiply it by. Okay. Okay, so it says recall that a regular polygon, so remember regular means all the angles and all the sides have to be the same, are congruent and all the sides are congruent. Equilateral triangles and squares are examples of regular polygons. In an equilateral triangle, each angle has a measure of 60 degrees, okay? And because 60, 60, 60 adds to equal 180, okay? In a square, each angle has a measure of 90, which we just said there was 2 triangles in there, right? So 2 triangles would be 180 plus 180, or 180 times 2, which is going to be 360, okay? Well, if I go 90 times 4, that's going to give us 360, okay? So there is a way, a formula that we're going to add to it now so we can figure out what one of the angles are, okay? Because the ones back here, when we wrote this formula, we were finding the sum of all of them. So what do you think you do when you want to find one of them? Anybody want to guess at that before we do it? Yes.
Divide by the number.
Close.
Or number of sides.
Number of sides. Awesome. Okay. So going on to fill in the rest. Okay, so we already have this filled in. Okay, you already have this. So we have 3, 4, 5, 6, and n. Okay, so for the sum of the measures of the interior angles, so we went 3 minus 2, which gives me 1, times 180 gives me 180. Okay, a quadrilateral was 2 triangles, right? So 2 times 180 gave me 360. Okay, we figured out the pentagon one because that was the one that we did on the bottom of the notes. So that was 5 minus 2, which was 3 times 180, which gave us what? 540. Okay, so 6 minus 2 gave me 4, and 4 times 180 gives you 720. Okay, and then we're filling in the actual formula here. So we went n minus 2 times 180 is what we did to fill in those. Okay. So Clary just said what our answer was for that. So now we go to find out what the measure of one interior angle is. We do this first, but then we're going to divide by the number of sides. Okay. So 180, which if you were paying attention on the previous page, I told you the answer to that, right, was going to be 60. Okay, and we had the answer to the 360 one. 360 divided by 4 gave us 90. Okay, so then we're going 540 divided by what? 5, which gives us 108. You want to find out what each one of them is. So you don't want to divide by the number of triangles. You want to divide by the number of sides. Okay, and then 720 divided by 6 is going to be 1. Okay, so now we're just writing the formula. So we write this formula again. So we got to do the n minus 2 times 180 first. Okay, then we divide by n. And n again is not triangles, it's the number of sides. Okay, we good? Okay, So the measure of an interior angle of a regular polygon, so it's the vocab second one down below your chart. We're just writing the formula here. So it's n minus 2 times 180 divided by n. Okay, so the key thing in this whole section is to make sure you're reading what they're looking for. Do they want all of the angles? Then you're not going to divide, okay? You're just going to do the n minus 2 times 180. If they want an angle or one angle, you need to make that number smaller, right? So then we divide by n. So you're just memorizing those two formulas basically is going to be the, no pun intended, sum of all of it. Okay, exterior. So you cut out on your triangle on Friday, we cut out these exterior angles and put them together, okay? And they added to equal what? Made us, right, 360. Your four-sided figure, when you put them together, was 360. And then your pentagon, when you put it together, 360. Anybody want to guess what all shapes, exterior angles add to equal? 360. Okay, so there is no formula on that one. Okay, so we are filling in. We already have this part filled in, this part filled in, this part filled in. Okay, we're just filling in this one. So the sum of the exterior angles, all of these going down, are 360. Okay, so that would be the sum of all of them, and it kind of makes sense if you think about what's going on the outside of the shape. Okay, they obviously, the measurement of each one of them gets smaller as the bigger the shape is. How do you think we could find out what one of them is on the outside? If we know the sum of them is 360 regardless of the shape. Divide by the number of sides. Okay, so again, when you're trying to get that smaller number, you're going to want to divide it, right? Okay, so going to, I think it's our last formula. Okay, so the sum of the exterior angles of a polygon is 360, but I want you to add this. If you need an, which means one, exterior angle, because they don't have it, that's your vocab. Then we're going to go 360 divided by the number of sides. I'm not sure why they don't have that in there. Okay, do you have one more column on there that we didn't fill in, the sum of the exterior and interior? Okay, so all we're going to do is add your interior and your exterior, which I believe they're right next to each other. Is that right? No, it's not right next to each other. So it's the 180 and the 360. I don't have it on my, it's on my next page, but we need to fill that in. Which one is it? It's your second to last one. Okay, so the, oh, I wanted a blank one up here. So the second to the last column, before your 360 that we wrote on the last one, so we would have 540, because it was the 180 and the 360. Okay, what would our next one be? So 720. What's our next one? 900. Okay, and then so then on our last one, we are just going to write n minus 2 times 180, and then we just add the 360. Okay, so again, this whole section, I'm going to get you started on the reteach. You're either using n minus 2 times 180 when we want all of the inside ones, okay? N minus 2 times 180 divided by n when we want one of them. And then the other one's pretty easy to remember. All is 360. To find one, then you're going to divide by n. So paying attention to the S's, like they'll say angles. then that's all of them. Okay? If there's no S, then you're going to want the other ones where you divide. Okay, so let me get the reteach handed out. Yep. Okay, so on the very first one, on number 1, we have a 1, 2, 3, 4, 5-sided shape. Okay, and in your notes, a 5-sided shape, right there, thank you. Okay, a 5-sided shape should add to equal 540. Okay. How could I find if I know 4 of them and I have the 5th one is missing? Right. So add them all up, right? So you're going to go 130, or you can subtract, I guess. I think it's easier to add. So go 135 plus 95 plus 110 plus 180. Okay, and then subtract that from 540. Okay. So we good on 1, 2, and 3? Okay. 4, 5, and 6, they're showing you what type of angles, where they're listed at. Exterior angles. So exterior angles, regardless of the shape, should add to equal what? 360. So you're going to do the same thing you did on 1, 2, and 3. You're just going to add and subtract from 360. We good on that one? Okay. Number 7, it says the sum of the measures of the interior angles of a 14-sided polygon is. So we don't want to have to try to draw and create a 14-sided figure, okay? So we just figured out a formula that makes it a whole lot easier for us to do. Okay, so 14 is the what letter that we had in our chart? The N. Okay, so I'm going to go 14 minus 2, which I know you can do this in your head. So 14 minus 2, which would be 12, and I'm going to multiply that times 20. Okay, a lot easier than try to draw it and, oh crap, like I have too many sides or too much, you know, and then not be able to draw your triangle. Okay, what if they said what is the measure of an interior angle of a 14-sided polygon? I would do that same thing, but I would need to divide by what? The number of sides, 14, not 12. Okay, but they did. Okay, 8, the sum of the measures of the exterior angles of a 7-sided polygon is 360. There's nothing to do on that one, right? It's just 360. Okay, they didn't ask for 1. Okay, number 9. So I'm going to start with 9, 13, and 17, and then I think I'm done talking. You guys can cut loose. Okay, so it says find the measure of an interior angle and an exterior angle of a regular polygon. So it means on both of those, you're going to be dividing by the number of sides. Okay, so on the first one, on number 9, which is 9 sides, okay, you're going to go 9 what? Minus 2, which would be 7, and then 7 times 180, which gives me 1,200, or 260. So we went 9 minus 2, right, which gives us 7, and then 7 times 180. Okay, that gives me all of them. In a sentence, there's no S on angles. Okay, so they don't want all of the angles, they want one of them. So I need to divide that by what? 9, not 7. This will be the common mistake if people look at that last number. Okay, it's the number of sides. Okay, so what did you get on that? Yep. 1 point. Okay. Also, on that one, they want an exterior. So I'm going to go 360 divided by 9, which is, anybody notice something about these two numbers? They add up to 180. So if you recall back on your notes when I said to draw a sketch of what we cut out, okay, when we have the triangle, right, you'll notice that we extended the side, okay? So that means that this inside one and this outside one is what you're looking at. Okay, that's what we're solving for, is an interior and exterior. So when you're finding these, sometimes it might just be easier, okay, to do the 360 divided by the number of sides, and then subtract that from what? 180 to find the inside. Okay, so that's why we drew it, so that you knew it wasn't like all of this. It's the one that when the side gets extended, okay, we found the inside, outside, and the two of them make a straight line, so they add to equal 180. Okay, so 9 through 12 will have two answers. Okay, now this one we have not done an example of, so I want to make sure you like actually write one of these out. Yeah, go ahead.
What'd you get the 40? Like, what'd you do with it?
360 is the outside angles, right?
Yeah.
But they want one of them. So you're going to go 360 divided by,
Oh, 360, okay.
right.
Okay.
Okay. Okay, so number 13, it says the measure of an exterior angle of a regular polygon is given. So they actually give you the answer to the formula, okay? And you're solving for n. So we have to recall our algebra skills on how to solve for these, okay? The last ones are the easier ones. These are the ones that you're going to want to write down the example, okay? So the formula for n is n minus 2 times 180 divided by n. So that's for n. And they tell us the answer is 174. Okay, so we need to recall some of our algebra skills from last year and trying to isolate variables. Okay, I'm going to go ahead and distribute because that's something I can simplify at top before I mess with the bottom. Okay, so this would be 180 n minus what? 360. Okay, I need to start isolating my n. How can I get rid of the n that is down here below the fraction? How do I move this? Multiply, right? Because it's divided by n, and we always do the opposite when we move things to the other side. Okay, so what I do to one side, right, to get rid of it, I've got to do to the others. Okay, so now I have 180 n minus 360 equals 174 n. So my next step to get n's all to one side. Move what? 180 to the other side, right? So it's a positive 180 n. So when I move it to the other side to get rid of it, I'm going to subtract, right? What I do to one side, I need to do to the other side. I always write it up above because subtracting is better to have a bigger number up above. Okay, so I have a negative 360 equals a negative what? So 6n. Okay, so my last step, a negative divided by a negative is going to get me back because you shouldn't have negative sides. You should have positive sides, right? But a negative divided by a negative is a positive. So 360 divided by 6, 60. So it's a 60-sided figure. Okay, you don't have to write sides. I'm just writing this so that you know it's not angles. Okay, so shortcuts. Since we went through it, so you'll know how to get to it, would be this part doesn't change, right? The only part that's changing is this. Because I would still get every single time, I'm still going to distribute the 180, I'm still going to get 360, I'm still going to move the n over to the other side. It's just this number that's going to change. So I just want to make sure you know how to get there, so when you go to do it in the future, you're going to know how to write that. Okay, so I'm going to change on 14, instead of having 174, I'm going to have 172. So I'm subtracting 172 from 180, which is 8, right? Okay, and then 8 gets divided into what? Because I'm right at this point right here, that's an 8. Okay, so if you have that written once, you can always refer back to that, because that just saves you time in distributing and getting your n by yourself. Okay, Last one. So the measure of an exterior angle of a regular polygon is given. How many sides does the regular polygon have? Okay, so this one's a shorter, I keep on doing that, is a shorter formula. So we have 360 divided by n, and they tell us the answer is 11.25. Okay, so just like the other one, to do this to the other side, I would multiply, right? That gets rid of it over here. What are we going to do to solve for n? If I have this. Right, 360 divided by 11.25. And that'll tell you the number of sides. Okay, that's the gist of this section. So tomorrow at the beginning of class, we'll grade these, go over these, ask questions. Again, keep your notebook in mind so you're not waiting until last minute. That could really help or hurt your grade. Hopefully it's for the better.